Hello everyone, welcome to my channel. We are on to the next video of aldehyde, ketone and carboxylic acid, and in this video I will be talking about conversions, all possible conversions of this chapter, and I hope the preparations are going on well. Just remember, hard work is key to success, and I'm sure you all will do well in board exam. Okay, so do not feel stressed, do not feel panicky at any time. Okay, so the first conversion which we are doing is butane 1-ol to butanoic acid. Now first thing is, whatever is given, you open up the structure and draw it first. That will give you a better picture of what conversion we are aiming for. So it's butane 1-ol. So I'm just drawing the carbon skeleton. That will be fine. Butane 1-ol, but and one position ol is there, and we are converting it to 4-carbon acid, COOH. Okay, now this is a simplest conversion where you are converting alcohol to acid. Alcohol to acid, the carbon number is same. So what are we doing actually? We can convert it in one step only. You can use potassium permanganate acidified. You can use potassium dichromate acidified. Okay, so this will be oxidized to the corresponding acid with the same number of carbon atom, right? The next one, benzyl alcohol, we are converting to phenyl ethanoic acid. Now what is benzyl alcohol? We will draw the structure first. Benzyl alcohol, C6H5CH2. This is benzyl radical. Benzyl alcohol, what are we converting this into? We are converting into phenyl ethanoic acid. So first you see ethanoic acid, 2-carbon acid, right? And then on this carbon atom there is phenyl. So phenyl ethanoic acid. Here there is no possibility because there is no bond available. Carbon already has 4 bonds. So it will be C6H5 here. C6H5CH2 COOH. This is what we are looking for. Now you can just see that the number of the carbon atoms. First check. Carbon atom number is increasing. This is 1 carbon apart from phenyl. 1 carbon and 1 more COOH. That means carbon has increased. Whenever carbon has increased, you think of potassium cyanide. So what we will do in this is, first thing is, we should convert this into, we should put some halogen over here. We should put some halogen. Suppose we are writing here SOCl2, thionyl chloride. That is the preferred reaction we have studied. So C6H5, you will have CH2, you will have Cl. Now this Cl, we have to increase the number of carbon atom. So what we can do is, we can add on alcoholic potassium cyanide. So you will have 1 more carbon atom, C6H5, CH2 and Cn. And Cn can be very easily converted to COOH. Just hydrolysis we have to do in the acid medium. Okay. So this one is clear. First convert to chloride, increase carbon atom with cyanide, and then cyanide, complete hydrolysis can be done in the acid medium. So either you write H3O plus, if not you can also write H2O/H plus. Even this is fine. Okay. We move on to the next conversion, which says 3-nitrobromobenzene. 3-nitrobromo means, we will say in benzene, bromo and nitro, 2 groups are present at 3 position, means 1 and 3. Okay, that means at meta position they are present. So we'll write Br here, and this is nitro group. Nitro group is attached here. Yeah, we are converting this into 3-nitrobenzoic acid. Now what is 3-nitrobenzoic acid? First let us draw this as benzene ring. Okay, so this is benzoic acid. First let us write COOH and 3 position nitro, means here you have NO2 group. You have nitro group. So that means we have not touched this nitro group at all. The nitro group is remaining the same. Only thing is, we have increased 1 carbon atom over here. So in this, just remember what one reaction we have done in acid. Okay, first you convert this into Grignard reagent.
convert this into Grignard reagent, means introduce magnesium. So what we do, we make it react with magnesium in the presence of dry ether. So what you get is, this is the benzene ring remaining intact. Oh, this is not here, this one is nitro is here, NO2, and here you will get MgBr. That means we have converted this into a Grignard reagent first. Now this is to be treated with carbon dioxide. This is to be treated with carbon dioxide. That means you will write down here dry ice. That is with CO2 you are reacting. How actually it is adding on? I hope you remember it. It is C double bond O. This like this carbon dioxide is. So this goes here. This will get a negative charge. Carbon gets a positive. So when this happens, so from here this ring part will be attaching here, and OMgR will be attaching on this carbon atom. We have done this reaction, complete reaction in acids. Okay, so I'm just writing the product in this case will be the ring of benzene as such. At the meta position nitro is also there. Here CO2 will be introduced in between. So what you will have is C double bond O. Here you will have OMgBr. Now you have to carry out hydrolysis. So in the acid medium you carry out hydrolysis. So how will the bond break? This bond will break from here. You will have H and OH. That means you are getting 3-nitrobenzoic acid. Clear? Now the next one is 4-methyl acetophenone to benzene 1,4-dicarboxylic acid. So first let us draw 4-methyl acetophenone. What is acetophenone first? Let us see this. It is a ring, right? And acetophenone is COCH3. This is acetophenone. And in this acetophenone, 4 position is occupied by methyl. We are preparing benzene 1,4-dicarboxylic acid in it from this. That means COOH and COOH. We want both to go away and get acid. You remember one reaction we have done in acid, wherein we are converting these ethyls. Had these two been ethyl, we can convert it into acid directly by KMnO4 KOH and just heating it. Okay, so what you do first is you carry out reduction reaction of it. Maybe zinc amalgam HCl. You will convert this into ethyl group. That means you will have one side methyl, the original one already present. The another one also will be ethyl now. This can now be converted into it by KMnO4 and KOH and heating it. Irrespective of the number of the alkyl radicals, all get converted into acid. It is that reaction which we have done in acids. Okay, now moving on to the next reaction. Cyclohexene. Cyclohexene we are converting into hexane 1,6-dioic acid. So what we are doing is cyclohexene, cyclic structure and a double bond. What are we preparing? Hexane means we are having a straight chain. In a way we can do like this. I have broken this bond, and here you are having COOH, here also you are having COOH. This is what we are doing it. Okay, so what we can do is we can directly heat this in the presence of KMnO4 sulfuric acid, or what you can do is you can first carry out ozonolysis. React with ozone in the presence of zinc and water. So it will break first, and you will get CHO here and CHO here. Aldehyde you will be getting directly. Now you can convert it, you can oxidize it in the presence of KMnO4 and acidified medium. You can get the desired product. Clear? Now butane al to butanoic acid. Butanal, 4 carbon atom aldehyde. you are preparing 4 carbon atom acid. Again, it is simplest, like you did the first one, alcohol to this thing, acid. This is aldehyde to acid, right? So you can just carry out the oxidation. It is the simplest one. You can use this one also. You can use this one. Okay, so you can use KMnO4 acidified potassium dichromate acidified. You can directly convert it into the corresponding acid. Clear? We are moving on to the next conversion, ethanol. Ethanol means CH3CHO. What are we converting this into? Butane 1,3-diol. Butane 1,3-diol means you have 4 carbon atom and 1 position and 3 position you are having alcohol. In this case, you are having but 4 carbon atom, al is there means aldehyde, and 2 position double bond. In this case, you have 4 carbon atom, double bond here and acid here. Actually, all 3 are having one step common. So that's why I just wrote them together. So what you do is, the first step is you carry out aldol condensation. That means when you carry out aldol condensation, it is CH3 CHO, 2 molecules. You have to carry out condensation in the presence of base NaOH. How will they add on? I hope you remember. How are they going to add on? It will be like CH3 CH double bond O, 1 molecule. Another molecule, you will open up that alpha H. Okay, so when you add on, this will go here. Okay, this will add on. And what will you get in the first step? You will get here CH3. You will have this as CH. You will have OH. This will be CH2 and CHO. This is the first step we got. Okay. So till here is common in all 3. From here, 3 steps, 3 different methods we have to follow. If I want to prepare the first one, instead of this CHO, I need alcohol, right? That means I will have to reduce it. So what I can do is, I can use NaBH4, LiAlH4, carry out its reduction. So I will get CH3, CH, this is OH as such, this is CH2, and you will get here CH2OH. This is the first one, you got it. The next case, you want this to be retained, you want water to be removed. That means from here, this only, you are going to heat it. When you heat, what will happen? H from here, OH from here will be lost as water molecule. 1 water molecule will be lost. So what will you get is CH3, CH, double bond, CH and CHO. So this is the second product you got. Now, you want a third product. Third product, you want this part as same. Only thing is, instead of aldehyde, now you want acid. You want acid. That means to get the last product, this was same. This is also same. From here you have to go to get the last product. So that means first carry out aldol, you get this product, get the second product, and now instead of this aldehyde, we want acid. That means you can use some Tollens reagent. Okay, you can use some oxidizing agent so as to convert this aldehyde to acid. So CH3, CH, double bond, CH, COOH. This will be your product. Clear? Right? Now, let's move on to the next, conversion. Next set of conversions. See, I've just written the structures to save time. Propanone, we want to prepare propylene. Okay, so first step what we can do is, we can reduce this CO part. We can reduce it. To reduce it, what you can do? You can use some reducing agent, maybe NaBH4 or LiAlH4. You reduce it to get alcohol. So you will have this OH and CH3. So that means what you can do is, from alcohol we have to dehydrate it. You have to dehydrate it. That is concentrated sulfuric acid you will use, such that it removes OH and H from here and get the corresponding alkene. First, ketone we have converted to alcohol, reduced to alcohol, and alcohol ka reduction. Now, benzoic acid we want to prepare, aldehyde. So what we can do, you remember Rosenmann's reaction. So first we will convert this into Cl. React it with thionyl chloride. When you react it with thionyl chloride, you will get benzoyl chloride. And now this benzoyl chloride, one step conversion you have, you can just react with palladium, barium sulfate. Okay, react it with H2 in the presence of and it is poisoned with quinoline. Poison with quinoline. Okay, so what you get is aldehyde. It's a Rosenmann reaction basically. Okay, clear? I hope the conversions are fine till now. Yeah, this one, ethanol to 3-hydroxybutanol. 3-hydroxybutanol. Let's see what is the structure. It is ethanol. Ethanol. No, alcohol they are saying. This is alcohol. Got it? Now, after this, what are you getting? 3-hydroxybutanol. That means but is there and 3-hydroxy. Oh, it's almost the similar one what we have done. Only the difference is, in this case, they are starting from alcohol. This is the similar one. I'll just tell you where we have done. We have done this reaction. It's basically this they are asking us to prepare. This is 3-hydroxybutanol. But this is from aldehyde. In the question which is asked is from alcohol. If you are asked from alcohol, what are you going to do? First you will oxidize this alcohol to aldehyde, and then from aldehyde you can carry out the aldol condensation. This is aldol condensation, which I told you. Okay, in case you are asked the other product like this, then you can go in this manner. Depending upon what they are asking, you have to go ahead. Okay, I hope this is clear. Alcohol, first you will oxidize to aldehyde, and aldehyde carry out aldol condensation. This is the conversion which I was telling you. Okay, it's a similar one. Once you start doing the conversions, you will have the repeated ones. You will automatically be able to think in the right direction. This is benzene. What are you converting this benzene into? Meta-nitro-acetophenone. So let's first write acetophenone. Just see acetophenone one conversion we already had, but that was slightly different, Here there is nitro group present. We want this way. Now what are we supposed to do? Right? Benzene, acetophenone. Acetophenone means we have to introduce acetyl group. So simple it is. You can carry out the reaction with acetyl halide in the presence of anhydrous Lewis acid, AlCl3. This is Friedel-Crafts acetylation. Carry out Friedel-Crafts acetylation. So in Friedel-Crafts acetylation you are getting acetophenone. Now this acetophenone you have to introduce nitro group. This is a meta-directing group because it's having a double bond. It will pull electron towards itself. Now you can carry out the nitration, concentrated HNO3, H2SO4, and then nitro group will be introduced at the meta position. Clear? Yeah, the next conversion is bromobenzene to 1-phenyl ethanol. The structure is here. We are increasing, in fact, 2 carbon atoms. 2 carbon atom we are increasing. Right? So that means you have to think of, Grignard reagent. You have to think of the addition to it. Acetaldehyde has to be added. So first what you do is you react this with magnesium in the presence of dry ether. So what you get is C6H5 MgBr. This is added. This you're getting phenyl magnesium bromide. Now this is to be added to this one, CH3CHO. I hope you remember how we were doing it. CH3CHO, acetaldehyde, nucleophilic addition elimination. No, addition reaction, not addition elimination, nucleophilic addition reaction. So how was this adding on? Suppose I add this to here. How was this adding on? it was adding like CH3, CH, this will be OMgBr, and the C6H5 part will be added on this carbon atom, and then you will have to carry out its hydrolysis. In the acid medium you have to carry out hydrolysis, so H and OH will be added on. So 2 carbon atoms you have added from acetaldehyde. First you convert this to Grignard reagent, this you add on to acetaldehyde, you get added product, and then hydrolysis. Benzaldehyde to 3-phenyl propane 1-ol. I have drawn the structure: prop, 1 position ol, 3 position phenyl. Okay, benzaldehyde you are converting into this. See, again in this, number of carbon atoms have increased. If you find more number of carbon atoms being added on, think of aldol. It's a crossed aldol reaction. So what you do is that you have to increase the number of the carbon atom by how many carbon atom we have to increase? 2. So what you will do is C6H5 CHO. This cannot provide alpha H. So alpha H will be provided by aldehyde which you are using. So it is this and CHO. You will add on. In the presence of the base the reaction is happening. So it will add on. What will you get? You will get C6H5 CH. Here you will have OH, and this will be CH2 CHO. We are getting this first. Okay, now when you heat it, this is going to lose one water molecule also. So you will have C6H5 CH double bond CH CHO. Now we are almost nearing to it. Now we want just adding of H2 here. So the last step, what you do is you have to just add on H2 in the presence of nickel, and then this double bond will go and you will get a single bond. Yeah, this is C6H5, this is CH2, this is CH2, this is CH2, and you get the product. Clear? Yeah, the next conversion is just 4 more conversions left. Please do not lose your patience. Benzaldehyde. What we are doing is C6H5CHO. You are preparing alpha phenyl, this thing, alpha phenyl acetic acid. So what you do is first you write acetic acid. Acetic acid means this COOH. Okay, so you want alpha position hydroxy, means this is main carbon, alpha position hydroxy, alpha hydroxy, and here you will have phenyl. So this is the structure. Whenever you want alpha hydroxy, think of adding HCN to it. HCN has to be added on to it. Like if it is HCN added on to it, you remember nucleophilic addition reactions, how we were doing? When HCN is added here, H will be added and CN will be added here. So what will you get here? C6H5 CH CN and OH on this carbon atom. Now we are almost closer to the product. This CN we have to just convert it into acid by complete hydrolysis. Clear? Benzoic acid to meta-nitro benzyl alcohol. Benzoic acid, that is C6H5COOH, benzoic acid. What are we converting this into? Meta-nitro. First let us draw this benzyl alcohol, C6H5 CH2OH, and meta position there is nitro. There are a lot of things done in it. This is benzoic acid. First work is converting this acid to alcohol. We have to convert this into alcohol. The next thing is we have to introduce nitro group in the ring. So what we can do is, first thing, we can carry out its nitration. In the presence of concentrated HNO3, H2SO4 and heat, you can carry out its nitration. That means benzoic acid, if I write like this, COOH, its meta position will be substituted by nitro. So one work is done. Now let's start working on this acid. You'll first treat it with, say, thionyl chloride. When you treat it with thionyl chloride, you are left over with this remains as such, and what you get here is COCl. Now we have to just reduce it. We want to just convert this into alcohol. So what you can have is NaBH4 and you have to just carry out hydrolysis. So this will go away and it will get reduced to alcohol. Clear? So moving on to the last two conversions. Toluene to trinitrotoluene. Toluene is methyl benzene. You are converting this into trinitrotoluene, means this is there and 3 nitro groups are introduced in the ring. It is just one step reaction. You have to you have to add on nitric acid, nitration mixture at 110 degrees Celsius. You have to heat it because this is orthoparadirecting. At this temperature all groups will be introduced in one go. Okay, the last one is propanoic acid to lactic acid. Propanoic acid, CH3CH2COOH. And what is lactic acid? CH3CHOH and COOH. On alpha position there is OH. Now just keep in mind, alpha position there is OH. So that means first you have to carry out its HVZ reaction with bromine, red phosphorus and HI. So on the alpha position you will get bromine. That is CH3CHBr and now we have to just bring in OH at this position. That means you can react with aqueous NaOH or KOH. You will get this in the group, that is OH you will obtain. So that means lactic acid is obtained. Okay, so this is all about the conversions in the aldehyde ketone acid chapter. In the next video I will be posting all the conversions which are included in amines. Okay, so please watch this video, practice the conversions till then, and all the best for your board exams.